Right, children, now we are in 2023 May, Unit 1. The question number is 4. This question says us, what is the electronic configuration of an oxygen atom in its ground state? What is ground state is? Ground state means oxygen's real state. There are two states. Ground state means O, like, right? Ground state means O. Oxygen sometimes has excited state. Excited state means O2 minus. If I write O2 minus, that is the excited state. So the ground state means the ordinary oxygen. The oxygen has 1s2. Oxygen's atomic number is 8, right? So how do we write that? 1s2, 2s2, 2p4. So in the p level there should be 4 electrons, right? So now look at here, 1s2, then 2s2 and 2p. 1, 2, 3, 4. In the p levels, when the electrons are filling, first they fill one by one and they couples. So now you can understand that. The correct answer is D. That's very easy. The next one is, which property shows, right? The next one is, which property shows the general decrease across the periodic table? Which property shows general decrease across the periodic table? General decrease. See the atomic radius. Atomic radii decrease down across the period, right? Sodium, magnesium, aluminium, right? Silicon, phosphorus, like that. What happens? Atomic radius decreases. Then what? So then atomic radius decrease across the period. We got the electronegativity. When I concern the electronegativity of these elements in the periodic table, when I concern the electronegativities of these elements in the periodic table, the electronegativity behaves like this way. Right? How this electronegativity behaves? You see this one, this is for the periodic table. Sodium, magnesium, they are less electronegative. What are the most electronegative elements? Most electronegative elements are fluorine, oxygen, nitrogen, chlorine, like that. The most electronegative element is fluorine. Next oxygen, next nitrogen. See that this side less electronegative. See this side more electronegative. So what happens across the period? Electronegativity increases. This side of the periodic table low electronegativity and this side of the periodic table high electronegativity. So what happens? The electronegativity increase across the period. So when I concern this one, electronegativity increase across the period. The next one, what happened to the first ionization energy? The first ionization energy varies like this. This is sodium. Imagine this is sodium and this is what? Magnesium, aluminium, silicon, like that across the period. Say that sodium atomic radius is high, magnesium atomic radius is less, aluminium very less. This is the outer electron. This outer electron is far away from the nucleus, so it easily release. This one close to the nucleus, difficult to release. This one very difficult. Here very difficult. So what happens? The ionization energy, first ionization energy increase. So we say that first ionization energy increases. Now we see what happens to the melting temperatures, right? When we concern the melting temperatures, see that sodium soft metal, magnesium little hard, aluminium is very hard, silicon is sand, or it makes a giant covalent lattice, so it's very hard. Melting point increases. So from sodium to magnesium, magnesium to aluminium, aluminium to silicon, up to silicon, melting point increases. After silicon, phosphorus, it is simple molecular structure. Sulfur, simple molecular structure. Chlorine, simple molecular structure. Argon, not molecule even, monoatomic gas. So then what happens? Melting point decreases. So up to silicon it increase, after silicon it decrease. So what I can see there, melting point up to silicon, up to silicon, it increases. After silicon, it decreases. So they ask which property shows a general decrease. So only the atomic radius decrease. So the answer is 5. Then I go to this one. See this. The first ionization energy of sulfur is lower than that of the phosphorus. This is the first ionization energy of sulfur is lower than that of the phosphorus. Which of the best explanation for this? The atomic radius of sulfur is greater than that of phosphorus. Electronegativity of sulfur is greater than that of phosphorus. The repulsion between the outer electrons in sulfur is greater than that of phosphorus. The shielding by inner shield electron of sulfur is greater than that of phosphorus. To answer this one, now we will go to the electronic configuration of phosphorus and sulfur. We see then how the electronic configuration of phosphorus and sulfur vary, and then we try to understand that case. Okay, now we got one thing, that is phosphorus. When I consider the phosphorus, atomic number is 15. So how do we write that? 1 is 2, 2 is 2, 2p6. Now it is 10. 3 is 2, 3p3. So when I draw this last shell, when I draw the last shell now, the last shell 3s2, how many electrons there? 2 electrons. 3p3, how many? The p level is divided to 3 orbitals like this. Now 3p3 means each contains 1 electron. So now look at here, in the phosphorus, completely filled, completely filled, completely filled, 3s2 completely filled, 3p3 half filled. So it's moderately stable. When I go to the sulfur, sulfur is 16. Right? How do we write sulfur? 1 is 2, 2 is 2, 2p6, 3s2, 3p4. So I will consider the third energy level. In the sulfur third energy level, it's like this, children. In the sulfur third energy level, so here there are 2 electrons, and in the p orbit divided into 3 orbitals, and then there are 4 electrons like this way. There are 4 electrons like this way. See this one? Here we consider the first ionization. First ionization means removing the 1 electron from the outermost. Okay, now which is outermost? In the phosphorus, this is the outermost. In sulfur, this is the outermost. So when I concern the phosphorus and sulfur, phosphorus half filled. Sulfur, these 2 electrons are in the same chamber. This electron is negative, this electron also negative. Now they repel because same charges repel each other. The repulsive forces occurs in between these two, make easy to shift 1 electron. So this repulsive force make easy to shift 1 electron easily. So this one, what is this one? Sulfur, right? What is this one? That is sulfur. Sulfur easily release electron compared to the phosphorus. So that should be the answer. So now see this one. Now see this one. It says the repulsion between the outer electrons of sulfur is greater than that of phosphorus. What do you think, children? Is that answer is true? Is that repulsion between the outer electrons in sulfur is high? This is sulfur. See the outer electrons in phosphorus, no repulsion. See the outer electrons in sulfur, here there are more repulsion because similar charges in the same chamber, so they repel each other. So 1 electron can be easily removed. So that is why sulfur's first ionization energy is less compared to the phosphorus. So then our answer is C. Right? C is the answer. I guess you understood it. Right? Thank you.